AP Physics 1? Today we're going to be applying our understanding, our foundational understanding of circular motion, and we're going to be applying it to certain problems, certain real-life problems. So without further ado, let's get started. Let's get a problem up in here. So we have a problem, and it asks us, what is the magnitude of acceleration? So let's write that out. What is the magnitude of acceleration? What is the magnitude of acceleration of a speck of clay? For some reason, my pen does not want to work today. Of a speck of clay. Okay, of a speck of clay at the edge of a potter's wheel, turning at 45 revolutions per minute. Okay, 45 revolutions per minute. If the wheel's diameter is 35 centimeters. So if the wheel's diameter is 35 centimeters. All right, so what is the magnitude of acceleration of a speck of clay turning at 45 revolutions per minute if the wheel's diameter is 35 centimeters? So I think the main thing we have to look for in this question, a main trick that that may be played on a physics test or on the AP test, is that they say diameter. We know in circular motion we have a bunch of formulas that have radius in the equation, but we don't have any formula that has diameter. So this means that we do have to make a conversion. We do have to make this 35 centimeters into a radius, and we also have to do an additional conversion that we will mention as we go on. But rule number 1 of physics: always draw a diagram. I will say that in every single one of my videos. Always draw a diagram. Okay, so we have a speck of clay, and it's turning on a potter's wheel. So we're going to do our best to kind of draw the circular motion of a potter's wheel. All right, so this is my best representation of the circular motion of a potter's wheel, and we have a speck of clay. And we'll represent it as that red dot. Okay, and it's this speck of clay, if it's turning in this direction. So let's say hypothetically this potter's wheel is turning in this direction. It tells us that it's turning at 45 revolutions per minute. Okay, it's telling us that its tangential velocity, because remember, velocity is always tangent to the circle, so its tangential velocity is 45 revolutions per minute. 45 revolutions per minute. And it tells us, the second thing that it tells us, is that from the center of the circle, this particle is 35 centimeters in diameter. Okay, in diameter. All right, I almost drew it as a radius, but I forgot. We did make that highlight. It's always good to underline the important stuff. Okay, this particle is 35 centimeters in diameter, meaning the whole circular motion has a diameter of 35 centimeters. Okay, so, and it's asking us to find its acceleration. And I will do that in a different color. It's asking us to find the magnitude of its acceleration. Acceleration is a vector quantity, so we might have also had to find the direction, but it's only asking for magnitude. Okay, so let's get started on this problem. So they give us a velocity. And they also give us something close to a diameter, or something close to a radius. So the first thing we have to do is let's convert this diameter into a radius. So how do we do that? Well, we simply divide the diameter by 2. So 35 over 2, we know that we have a radius of 17.5 centimeters. But once again, in physics, centimeter may not be the best source of unit because a lot of our velocity quantities and acceleration quantities are in meters per second squared. So I think the first thing we can do is convert this 17.5 centimeters into meters. So how do we do that? Well, we do 17.5 centimeters, and we do some simple unit analysis here. So centimeters, we want to cancel. We know 1 meter, oh, that looks like an 11. 1 meter equals 100 centimeters. So we do 17.5 centimeters over 100 in our calculator. You probably don't even need a calculator, and we get 0.175. Ooh, that's kind of messy. We get 0.175 meters. Okay, so this is our radius. All right, and I will erase this. We already kind of showed that work. If you need to see the work, please go back and pause the video, but we already kind of showed it. So we have our radius to be 0.175 meters. Okay, so now we have a velocity and we have 0.175 meters. So we know if we want to find acceleration, which is actually centripetal acceleration because it's circular motion, if we want to find our acceleration, which is centripetal acceleration, we know that we have a formula for that. It's the tangential velocity squared over your radius. Okay, so let's put our tangential velocity of 45 RPMs and our 0.75 meters down here. Oh, wait, we can't. We have revolutions and we have meters. Those are two completely separate quantities. So let's convert this 45 RPMs into meters per second. Okay, let's try to do it into something that we're familiar with. So I'm going to kind of divide this and put it in a different color. Divide this board for the conversion. All right, so 45 revolutions per minute, and I want to convert that into meters per second. So minute and seconds, and revolutions on the bottom so that it can cancel out with the top revolution, and meters on top. So we know that 1 minute is 60 seconds, and we know that 1 revolution will be the circumference of this circle, because think about it. If this particle at the edge of this potter's wheel was to travel 1 total revolution, it would be traveling the total circumference of this circle. So it's just pi times its diameter. So pi times, well, we have 35 centimeters. We can't have centimeters. We want it in meters. So 35, we'd have to divide by 100. So it would get pi times 35, in fact. So it would be 0.35 pi. Because we want it in meters. And now it just comes, so revolutions cancel, and minutes cancel. So we're left with meters and seconds. So that's what we want, and that's what we're going to get. So we do 45 times 0.35 pi, and we get 49.48. And if we divide that quantity by 60, we should get 0.82 meters per second. All right, we converted into something that we're a little bit more familiar with from our kinematics and dynamics from those days. All right, so let's plug those values in. All right, and sorry for the 2 different colors, but all right, so our tangential velocity, 0.82 meters per second, and we have to square this entire quantity, and we divide it by our radius, which is 0.175 meters. Okay, if we divided, if we do unit analysis here, meters over second squared is meters squared over second squared, and if you divide it by meters, you'll get meters per second squared. Okay, so we know that all our units are in place. It's now just typing it into our calculator. Okay, so we do 0.82 squared, which is 0.6724, and you divide it by 0.175, your radius, and you get your centripetal acceleration to equal 3.84 meters per second squared. All right, so this would be our centripetal acceleration. Now, because this problem didn't specify certain units, it didn't ask you to put the acceleration in revolutions per minute, you don't have to convert meters per second squared into, into revolutions per minute or revolutions or anything like that. You don't have to make any sort of conversion because it did not indicate anything like that. So this would be perfectly acceptable. It's perfectly legal. They did not ask for any specific units. So your centripetal acceleration, or the magnitude of your centripetal acceleration, would be 3.84 meters per second squared.